Hello everyone, welcome to day 17 of distance learning. If you haven't already, please make sure that you answered the attendance question for today as your first task. Your second task should have been to check the comments and read the answer key to the day 16 assignment, which was the 5.1.1 worksheet, the 4 problems where you had to find the inverse function. And all you need for this video is either a printout of these 5.1.2 inverses notes, or you're just copying down into your notes for your reference in your math notebook. You probably should need a ruler for this as well, since we're going to be drawing some lines. But you can also use the straight edge of a paper to connect the dots as well. So let's just get started on inverses. So we just started a new chapter last Thursday, and the first half of this chapter we're learning about inverses, and basically inverses is just the mathematical term for backwards. So we're finding a backwards function. We're finding a function that undoes one that we're given. Okay, so let's just start copying. So when given a function f of x, the notation for the inverse of the function is f to the negative 1 of x. So if you're given a function called g or h or z or whatever, you're going to write g to the negative 1 of x, or h to the negative 1 of x, or z to the negative 1 of x. This negative 1 is just notation that you have found the backwards function that undoes. Note that the negative 1 is not a negative exponent. It is the mathematical symbol that indicates the undo or the inverse function of f of x. So moving along, when you look at the graph of a function and its inverse, you can see a symmetrical relationship between the two graphs demonstrated by a line of symmetry. And this line is y equals x. And I'm going to explain this further when we actually graph these inverses, but on your assignment from last Thursday, Friday, on the day 14-15 assignment, the second to last problem was that you had to choose one of the pairs of functions and their inverses to graph, and you saw that they were the same. For those of you that did it, that they were the same graph, same shape. The lines that I drew both were increasing, and they also do have a line of symmetry, and that's the relationship between a function and its inverse. And again, I'll show you when we do the examples down here. So before, when I had you guys finding the inverse or finding the backwards function, especially in the packet, if you saw the answer key, I would have you list out what the function is doing to the x, and then you would reverse the order and completely undo everything in those steps, and then you would write your new function with the new notation with the negative 1 exponent. There actually is a bit of a simpler way to do it. So the reason why I'm taking a video today is because this is the official way to find an inverse. So instead of listing everything out, reversing the order, doing the backwards of every operation, and then rewriting your new function, the simpler way is to just replace f of x with y in the original equation. Or if you have h of x, g of x, l of x, just replace it with y. Then you're going to interchange x and y. That means you're going to switch their place in the function, because we're finding the backwards function, so you're just switching x and y. And then you're going to solve for y again. And then that'll just get you the inverse in the end. Let's do some examples. We're going to follow these 3 steps. So examples: find the inverse of each of these 2 functions algebraically, then graph the function and its inverse. So right now we have f of x equals 1/2 x plus 3. So before, I would normally have you say, okay, well, the first step that we do is we multiply the x by 1/2, and then we add 3, and then you would reverse the order, and then you would write, or do the opposite, and then write the new function. So then you'd have to do the opposite of adding 3, which is subtracting 3, and then your last step is the opposite of multiplying by 1/2, which is multiplying by 2, and then you would write your new function. That's a little bit much to think about, so really just follow these steps and it'll get you the same thing. So replace f of x with y. Instead, I'm going to have y equals 1/2 x plus 3. Then I'm going to switch the x and the y. So now the x is going to go on this side, and the y is going to go next to the 1/2. And then your last step is to just solve for y. So how do you get y alone? Well, we have to move the 3 to the other side, so I'm going to subtract it. And how do you get rid of multiplying by 1/2? Well, you can divide both sides by 1/2 and then do state change flip when you're dividing by a fraction. Or another way to get rid of 1/2 is to just multiply by 2, because if you do 2 times 1/2, it just turns into 1. So I'm just going to multiply both sides by 2. So that's 2x minus, or you could have just kept it as 2 times x minus 3. I'll just do that first. And you can see here that we've done the opposite. So instead of adding 3, we're subtracting 3. Instead of multiplying by 1/2, we're multiplying by 2. And then your last step can just be to use inverse notation. So I'm going to go back to the f of x. I'm going to write f to the -1 of x. That shows that we found the backwards, the inverse function of f of x. And I'm just going to distribute. It's 2x minus 6. So these two functions are opposites of each other. When you graph them, you're going to see that they're the exact same shape. They're both lines because they're in y equals mx plus b form. And then you're going to see something else, and I'll show you exactly. So our next step is we have to graph each of them to see what they look like. You can use Desmos, but just make sure that your graphs are accurate. I'm just going to graph using y equals mx plus b. So here I put a dot on 3. I'm going to use different colors. So put a dot on 3. And a slope of 1/2 means up 1 over 2. Or down 1, left 2, same thing. And then let me put my phone down. To connect with a ruler. And I'm going to label this with f of x. So that's my first line. And then my second line is going to be done in purple, my inverse. I'm starting at -6. Which is just 1 slot down there, and then I'm going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Now they may or may not intersect, and these eventually will somewhere up here. Let me put this down and connect the line. You'll see here that they're the exact same shape. They're both lines and they're headed towards this direction. So basically the graphical relationship was, when you look at the graph of the function and its inverse, you can see a symmetrical relationship between the two graphs demonstrated by a line of symmetry. This line is y equals x. So anytime you graph a function and its inverse, they'll be symmetrical to each other about the line y equals x. I'm going to graph the line y equals x. You are not required to do this. I'm just showing you for this example. I'm going to graph it in pencil. The line y equals x starts at 0. Your b is 0 because it's not there. And the slope is 1 because that's the number in front of the x. So you're going up 1 over 1, up 1 over 1, up 1 over 1. I'm going to connect without a ruler just so I can get my point across quicker. There you go. Pretend that's a straight line. But basically, anytime you graph a function's inverse, they're going to be symmetrical to each other about the line y equals x. So pretend you put a mirror here, and then you'll see the reflection of these two. They're completely symmetrical across that line. And that'll happen anytime you graph a function and its inverse. Let's do another example. We have g of x equals x minus 3 over 2. Like I said, they don't always have to be called f, and that's okay. So our first step to find the inverse algebraically is replace f of x or g of x with y. Our second step is to switch the x and the y, interchange them. So the x is going to go here and the y is going to go here in front of the -3 in the numerator. And then our last step is to get y alone, solve for y. So I have y minus 3 divided by 2. If I have dividing by 2 to get rid of it, I'm going to multiply both sides by 2. I have 2x, these cancel out, equals y minus 3. And then my last step is to add 3 to both sides. make sure you're always writing back into the function notation with the inverse. This was called g. So g to the negative 1 of x equals 2x plus 3. And I realize in this problem I never labeled this as f to the negative 1 of x. I'll do that right now. Okay, so x minus 3 over 2, the backwards function or the inverse function is 2x plus 3. And you can kind of see that, you know, we did the opposite, dividing by 2, multiply by 2, subtract 3, add 3, but they're in a specific order. We multiply by 2 first, and then we add 3 in our inverse when we solved for y. Our last step for this now is to graph both and see that symmetrical relationship again. Both of these are going to be lines because they're in y equals mx plus b, or another way to see that is they have the exponent of 1. So anytime you have like x to the first in an equation, it's always going to end up being a line. For this one, I'm just going to do my division so I can see my slope and my b. So g of x equals, technically there's a 1 in front of that x, so this is 1/2 x. And then divide here minus 3/2, which is the same as negative 1.5. Let's graph that in pen. So negative 1.5 is somewhere around here. And then I'm going to go up 1 over 2 for a slope of 1/2. I'm going to put my phone down. Here's my first line, the original. Label that with g of x. Now I'm going to graph in purple my inverse, 2x plus 3. So start at 3, go up 2 over 1 for a slope of 2. If you don't like graphing like this with y equals mx plus b by hand, just use Desmos. Type both of them into Desmos and copy the points accurately. And you should be plotting on labeled axes, x, y. You should scale if you need to. So far we haven't. We've been counting by ones. And I label this with g to the negative 1 of x. And now you can see here, if you were to draw that line, y equals x right in between them, just like this one, they would be perfect reflections of each other over that line if you were to put a mirror there. Okay, so that's basically how you find an inverse without having to list out the steps, do the reverse order, and do the opposite operation of everything. You kind of just change the function notation to y, switch the x and y, and then solve for y, and you're done. Graphing is just an extra part that I had you do, and you will have to do this on your practice for today. So make sure you use Desmos, right? You're graphing accurately if need be. If you get something that isn't a reflection of each other, you know that you've done something wrong. So if you have any questions, please comment on Google Classroom or email me. We have one more to do. Guys, anytime you see like a mini number next to a variable, it's always an exponent. Remember, I have had trouble with formatting on my Word documents on my laptop. So this is x squared minus 9. Okay, first step, change the h of x to y. Second step, switch the x and the y. Last step, solve for y. So what's blocking it from being alone is the squared and the negative 9. Remember, you're working backwards from PEMDAS to solve, so you should be getting rid of subtraction first before the exponent. Add 9 to both sides. Then we have to get rid of the square. The opposite of squared is square root. And make sure you do plus or minus. And this can't be simplified anymore, so make sure you do not separate it into root x, root 9, which is 3. You can't do that when there's a plus or a minus sign in between. You can totally do that with multiplication and division inside the radical, but you can't do it for addition or subtraction. So that one is simplified all the way. And then we're going to convert back to the notation. So h to the negative 1 of x is plus or minus square root of x plus 9. I'm going to graph this one using my Desmos, so I can show you how I do that. X squared minus 9. And I'm just going to pick some points and connect the dots right here. So it looks like the vertex is at 0, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have the intercepts at, x-intercepts at -3 and 3, 0. If there's anything else that I can have, I'm just going to connect right now to the best of my ability. You guys can obviously graph more points since you have more time than I do. But h to the -1, that's h of x, not h to the -1. That's just the normal function that we are given. Now we're going to graph this one. Be careful with plus or minus. You have to graph them separately. So I'm going to delete my x squared minus 9. And then I'm going to get my square root, which is right here. I'm going to graph x plus 9. And then I'm going to graph the negative. Anytime you have plus minus, it's two different graphs. So one positive, one negative. And you'll see here that it's sideways now. It's pretty much the same thing. Look, you have your -9, 0, it's switched. You should be doing this in a different color. And you'll see here that instead of your x-intercepts being 3 and -3, now it's your y-intercepts that are 0, 3, and 0, -3. And that plays a significant role with inverses. And it'll help you with the next problem that we're doing on the notes too. Okay, and there's the inverse h to the -1 of x. If you have any questions on the solving part with the switching and then the graphing, please comment down below or on Google Classroom. And you'll see here that if you were to put a mirror on that line y equals x, there'll be perfect reflections of each other across that line, okay? The last part that we're gonna do is some more graphing. So graphing the inverse using a table. You're not gonna find the inverse, you're just gonna find the table of the inverse, and you're gonna label the graphs with their equations like we've been doing so far. So basically, you're just gonna get a table for the original function. We'll do j of x equals 1/4 x minus 2. You can look on Desmos for points, or you can just make up your own table. It's really up to you what you would like to do. But I think I'm just gonna make my own table. So I'll plug in like 0, I guess would be the easiest. If you plug in 0, you do get -2. Since I have to multiply by a fourth, you can plug in whatever number you want and get decimals. I want whole numbers, so if I do like 4 times 1/4, it'll make a whole number and make it easier for me to graph. 4 times 1/4 is 1, and 1 minus 2 is -1. If you do multiples of 4, like this will always turn out as a whole number, because 1/4 times a multiple of 4 will always give you a whole number. That means I'll do 8 next. 8 times 1/4 is the same as 8 divided by 4, which is 2, and 2 minus 2 is 0, and I'm just going to plug in the negatives on this side. And -4 times 1/4 is -1, -1 minus 2 is -3, -8 times 1/4 is -2, -2 minus 2 is, again, you did not have to do this in your head like I did. You can use a graphing calculator if you have one. You can use your own calculator to plug in the numbers, or you can use Desmos to copy the points, okay? So this is going to be for j of x. The next table is going to be the table for the inverse. Well, how are we supposed to know that if we didn't solve for it? Well, since they're accurate reflections of each other, and I kind of give you a hint that, see, this one went from 9 on the y-intercept, and then the inverse had, sorry, -9, and the inverse had -9 on the x-intercept. Well, everything just switches. So if this coordinate for the original function is -8, -4, then the inverse is going to have -4, -8. And this relates to that 5.1.1 packet that you did last week on Thursday, Friday, because the tables just reverse. Literally just switch all the x and y's. And that's pretty much all you need to do. And you just have to graph. And actually, do we have to label the graphs with their equations? Okay, I guess we do have to find the equations, but that's just the gist of switching all the coordinates. Pretty straightforward. Since we have to label the graphs with their equations, I'm going to find the inverse actually. So that's y equals 1/4 x minus 2. Switch the x and the y. And then solve for y. I'm going to add 2 first. Work backwards from PEMDAS when you're solving for a variable. You get rid of addition and subtraction, then you get rid of multiplication and division, then you get rid of exponents. The opposite of 1/4, multiplying by 1/4, is multiplying by 4, because that'll make it 4 times 1/4 is 1. So I'm just going to convert back to the notation. J to the negative 1 of x equals, I'm going to distribute 4x plus 8. And we're just going to graph. I'm just going to graph using y equals mx plus b again. This is going to be in pen. At 1 over 4. Down 1, left 4. Use Desmos if you need to graph, if needed. Use a ruler, unlike what I'm doing right now. And then here we're starting at 8. I'm going to run out of room, so let's see if I can graph any of these. -3, -4. Let's use a different color. Again, I'm just graphing from the table because I don't have enough room to fit 8. -2, 0. -1, 4. And that's pretty much what it looks like. Connect with a ruler. And that's j to the -1 of x. Again, I checked to make sure I have my mirror on y equals x, and it looks like they're perfect reflections of each other. We only have one more to do. Again, that's a cubed. Anytime you see a mini number, it's an exponent. Okay, so we can plug in our own numbers again, or you can just go in Desmos and copy the points. I'm just going to plug in my own numbers. So, like, I'll just start with, I guess, 0. Or you could do -1. I'm just choosing numbers that won't, since I'm cubing, like that won't give me outrageously large numbers that I need to graph. So if I have -1 minus 2 is -3, and -3 cubed is the same as -3 times -3 times -3, which is -27. So that's a bit too much to graph, which is fine. The table still counts, but I'm probably not going to graph that. If you plug in 0, you get -2 cubed, which is -8. If you plug in 1, you get 1 minus 2 is -1, -1 cubed is -1. Plug in 2, you get 2 minus 2 is 0, 0 cubed is 0, and 3 minus 2 is 1, 1 cubed is 1. So these I can probably graph, and that'll get me my, who remembers what a cubic looks like? We'll find out if you don't remember. And eventually end up graphing it like that. And then I'm basically just going to switch all the coordinates. This is going to be my inverse. So this is original. My inverse is going to have all the flipped coordinates. Make sure you're labeling them with what they are. Just literally flip all the x and y. So all the x and y becomes yx. 0, 2, 1, 3. And then now I'm actually going to find my inverse because we're required to label the graphs with their equations. So switch the k of x to y. Switch the x and the y. And then now we just have to solve for y. So we have to get rid of the cubed first because the -2 is in parentheses, and you always get rid of exponents before parentheses. The opposite of cubed is cube root. Cube root both sides. If you cube root both sides, the cube just cancel out. So I'm just going to write y minus 2 left over. Last step is to add 2. Be careful that the adding 2 is on the end and not within the cubed root because we did the cube root first. So that's only over the x. Flip back to the k to the -1 of x, inverse notation. And we're going to graph that in purple. Again, you can put these in a Desmos or just copy the points. It's up to you. And I'm probably just going to copy the points. So 0, -8, 1, -1, 2, 0, 3, 1. I should add another point to graph. Let's do 4. 4 minus 2 is 2. 2 cubed is 8. And I have 0, -8. Oh, look at that. It makes that S shape. Cubics are always S shapes. So in pen we have k of x equals x minus 2 cubed. And then we graph the other one, and we have negative 8, 0. Everything is reversed. Negative 1, 1. 0, 2. 1, 3. 4. And then this becomes 8, 4. I'm going to turn on its side. And I see that I still have my S shape, but it's kind of going the other way now. It's flipped. And again, it would make sense that it's flipped because inverse means backwards. I'm labeling with its equation, and I'm pretty much done. Cube root of x plus 2. These notes will be attached to the post for today if you would like the answer key outside of this video. And again, I forgot to label this with the equation. So j to the negative 1 of x. This is actually the regular one. 1/4 x minus 2. And this is 4x plus 8. So again, these notes will be attached to the post. Use Desmos if needed. Use a ruler. Unlike what I did towards the end, I got lazy, but in the front, I did use a ruler. If you have any questions, again, comment down below in the video or comment on Google Classroom or email me. Your assignment is the packet that's attached in the post. You have 2 days to watch this video and complete this assignment. So you're gonna do the same thing. Find the inverse equation algebraically. You're gonna follow the 3 steps. Make sure you use your function notation, which is the negative 1 exponent. Remember, it's not really an exponent, sort of. It's just notation to find the backwards function. If you have any questions on any of these, you need to let me know. Right, you should not be handing in an assignment unless you've gotten all your questions answered. Remember, that's a squared. Squared. And then you're gonna do the same thing that we did, was make the 2 tables, right? This is just 5 times x minus 2 and 3x plus 2. Graph either using Desmos or the tables, and it looks like you have to do the same thing, was label their graphs with their equation. So you need to find the inverse with 3 steps again. That's a squared. Cubed. That one stayed for some reason. And then you have a few extra problems. Again, you have 2 days to complete this assignment. Let me know if you have any questions. I can't ask enough. Ask me questions, please. Good luck and have a good Tuesday and Wednesday. See you guys. Bye.